Welcome to Geometry. Today's lesson is going to take a look at cylinders and cones. And here we have a very interesting rotating quadracone picture. Let's go to your notes and start looking at cylinders. So a cylinder generally refers to a right circular cylinder with its ends closed to form two circular surfaces that lie in parallel planes. Is a cylinder a polyhedron? In many ways, a cylinder is similar to a prism. It has parallel congruent bases, as does a prism. But the cylinder's bases are circles rather than polygons, and therefore it is not a polyhedron. Well, let's take a look at lateral and surface area of a cylinder. The lateral area, remember, excludes the bases, and therefore we would not include these circles, and it would just be the area of a rectangle. A rectangle whose length is the circumference of the circle forming the base, and whose width is the height of the cylinder. To just get the lateral area, I would multiply the height by the circumference of the base. To get the total surface area, I would then add in my area of each base. I can write that formula in two different ways. Now, you do want to be careful when solving problems related to the surface area of a cylinder. You'll see three different types of problems, some where you will exclude the area of both bases, some where you will exclude just the area of one of the bases, and some where you will include the area of both bases. So you have to read the problems carefully to determine which type of problem you're solving. And of course, volume of a cylinder is just area of the base, which is a circle, times the height. Pretty straightforward. Now let's talk about cones. Cones generally are a right circular cone with its end closed to form a circular base surface. The vertex of the cone is not in the same plane as the base. In many ways, a cone is similar to a pyramid. A cone's base is simply a circle rather than a polygon, as we saw with the pyramid. So we're going to have 1/3 area of the base times the height, so 1/3 pi r squared h for the volume. This is where you're going to want to pay attention, not be looking at the clock, because this is how we're going to derive the surface area formula for a cone. So if we think about these two components, the radius of the base of the cone is going to give me the area of this circle. The slant height of the cone will be the radius of the sector that I'm referring to. Note that the length of the arc in the sector is the same as the circumference of the small circular base. So we can use that to write a proportion to solve for the area of that sector. If I say the area of the sector is to the area of the circle as the arc length is to the circumference, I can write this proportion. I don't know the area of the sector. I know that the area of the circle, this entire circle, would be pi s squared. And then I know that the arc length is 2 pi r, because remember this arc length is equal to the circumference of the small circle, is to the circumference of the entire large circle for which I have the sector. And then I can solve for the area of the sector, simplify, and I get s pi r. So that's step one. And then to get the lateral area, it would just be that s pi r, and the base area would be the area of the circle. So for the entire cone, the surface area is s pi r plus pi r squared. And then if I want to find the slant height, I can always use Pythagorean theorem. Again, you will need to be careful when you're solving problems related to the surface area of the cylinder. Do I need the lateral area or do I need the total surface area? Always ask that question. So that's all I have for today. We're going to practice some of these problems and then continue on our exploration of solids. Have a great day.